Hello everyone, welcome to Nature of Propagation of Light, verifying laws of refraction using Hyugen's principle. Now here, I'll give you some steps to make the figure, to make it clear for you guys on how to make the figure. So first, you have the refracting plane surface. So like this, not the surface but the medium. So this is air, meaning this is the rarer medium, which I'll write rarer, and this is denser. Now we know when light goes from rarer to denser medium, it bends towards the normal. So first, this is our xy. So this is our first step, xy. Then here we have a wavefront like this. Let's just say AP. Second is AP. Now we have rays of light associated with this. Now the first four steps are basically the same as that of the laws of reflection. LA and MP. Now we draw our normal. This becomes our incident ray for AN. Now in the reflecting part, when P goes to P dash, A reflects to AA dash with the same distance. But here, when P goes to P dash, like this, A refracts to AA dash but with less distance. So here, let's just say AN, here that means this is also the normal. So it bends towards the normal like this. But this, yes, this AA dash should be shorter than PP dash. So now here we join A dash and P dash like this, and now here we draw our LA and our rays of light associated with this as well. So what we had just done is 5. Well, before that, let's just use Huygens principle, which is two postulates. Just like in the reflecting part, we have said that the second one, the forward tangent of the wavelets, give the secondary wavefront, which is A dash P dash. That means there must be some number of points on the primary wavefront to give these secondary sources of wavelets, right? So here, the primary wavefront is actually the xy, the refracting plane surface, and here AA dash is actually the radiuses of the wavelets to which the forward tangent gives A dash P dash. So here, this is a wavelet, so B dash. This is another wavelet, C dash another, and so on, so on. Now here, let's make our rays of light. So here, like this. Sorry, not outside. I'll make it inside the figure. L dash, and here this also bends towards the normal, right? So this should be parallel like this. P dash, I'll make it like that, right? These two seemingly parallel. Now here we have to draw our normal. So this is our reflecting angle. Now let's just write down the steps we did. We have AA dash due to the PP dash, and now we have number of points AA dash, PB dash, CC dash, which gives our secondary wavefront, right? So here in the last step we had drawn L dash, A dash and P dash, M dash. I'll make it the similar like that, M dash, P dash. Ninth step we drew the normal, which let's say P dash, and let's just say N dash, right? So P dash, N dash, and that is our 9 steps to drawing the figure. Now for the laws of refraction, first we have to verify Snell's law, which says that the sine of the incident angle by the sine of the refracting angle is always constant for a pair of two mediums. So basically we have to verify mu is equals to sine I by sine R, which is constant. Now here we have to use again, like in the reflecting part, that angle between any two lines is equals to the angle between their normals, which means that this is angle I, and this here, if R is here, then this is angle R. Now here this is 90 degrees, and we believe this is also 90 degrees, right? So here we have to take the help of two triangles. So triangle A, well actually we don't have to take triangles in this one. Now here, first of all, let's use some logic, right? So when the time required, the time taken for when P goes to P dash is the same for A dash. Although the distances are shorter, A dash, the light travels slower through a denser medium, and this faster but a longer distance. So here their time is equal, so time equals to time dash, let's say, right? And we know that speed equals to distance over time, s by t. So that means time is equals to distance by velocity. So here our distance for, let's just say, pp dash is, well, this is in air, so this is c, the speed of light, which is a dash, and let's just say a velocity v. Now let's rearrange it that pp dash by a dash is equals to c by v. Now what we need is our sine I and sine of r. So our sine of angle I, sine I. So from this triangle APP dash, we have sine I equals to PP dash by AP dash, and our sine R is equals to, from here, AA dash PP dash, we have AA dash by AP dash. Now let's just divide sine I by sine R, which is, well, this divided by that, these AP dash cancels, giving PP dash by AA dash. Now from these two, we can see that this is equals to C by V. So here, from here, well, we basically get this part, right? Sorry, we got this part. So that means we got our mu is equals to C by V. And here, for any two pair of media, the speed of light in air by speed of light in that medium is always constant for wherever you are on, or are on Earth, right? So this gives constant. So therefore, well, Snell's law is verified. Right? So here, that is it for laws of refraction, and you can also say that they all lie in the same plane, like the incident, the refracting, the refracted ray, all lie in the same plane. Hence, the laws of refraction are verified. Thank you.